This lecture is about software security. Patterns are tested and proven design solutions for commonly encountered design problems. Recurring software security problems can be solved with software design patterns. Common security issues are protection of data transferred over the Internet and authentication of users for access to specific information. These security issues can be resolved by a secure pipe pattern and a checkpoint pattern, respectively. An example of an architectural security pattern is the privilege reduction pattern that aims to compartmentalize the system by decomposing it into mutually distrustful components. Another architectural pattern is the checkpoint pattern. Its aim is to organize the checking of security policies and to execute countermeasures. An example of a design security pattern is the roles-RBAC pattern. Its aim is to structure and manage role-based control, and it supports hierarchical roles and resources. A security pattern at the implementation level is the secure pipe. Its aim is to secure the connection between the client and server and between servers that require mutual authentication, confidentiality, and acceptance. A possible secure architecture for the SAMS system. Several patterns are applied. The single access point module includes the patterns of single access point and the privilege separation. The users are assigned the latest privilege and access the system through a single entry point. The privilege reduction pattern is applied to the architecture because the system is structured into compartments that require different levels of privilege to access. For this discussion, the modules are labeled with the pattern names, such as the single access point, checkpoint, and so forth. The controllers use the checkpoint module to check the security policies. The login controller authenticates users using the checkpoint policies, and the checkpoint uses the university's authentication, which is an application of the defer to kernel pattern, where the authentication is deferred to the university server, and it uses communication resources secure software design principle by using authentication that has already been tested by university users. The apply online controller uses checkpoint to authenticate user access to the online application. 7 best practices in software security are code reviews, architectural risk analysis, penetration testing, risk-based security testing, misuse cases, security requirements, and security operation. Code review can find implementation problems, omissions, misunderstandings, and naive assumptions of trusting too much. Architectural risk analysis can identify design flaws in the architecture, poor compartmentalization, inadequate protection of critical assets, failure to control role-based access to resources, and failure to authenticate. Penetration testing performed during deployment and in the field operations can find architectural design flaws, the security problems related to configuration, and environmental factors. Risk-based security testing performed during unit testing and system testing phases ensures that the security functionality works correctly by performing security tests derived from attack patterns and risk analysis. Misuse cases are identified during the requirements phase, are modeled and analyzed to gain insight into potential security issues. Security requirements identified during planning specify the required protection of assets and promotes the importance of security. Security operation performed during the system operation is aimed at setting up monitoring and understanding behavior of the system that could lead to successful attacks. Architectural risk analysis and misuse cases benefit from the use of attack trees, which are derived from the fault tree analysis technique. An attack tree or fault tree is an and/or tree used widely in problem solving. The nodes represent problems or goals. There are two types of nodes, the AND node and the OR node. An AND node means that the problem is solved if all of its child problems are solved. An OR node indicates, which is the default, indicates the problem is solved if one of the child problems are solved. Attack trees facilitate architectural and behavioral design of secure software. Branches of the attack tree specify possible ways an attacker might attack a system. The attacks with high occurrence probability and significant danger to the business should be taken into consideration during the design process. During the software lifecycle, software security activities must be performed. During planning and designing, security requirements are identified through the domain model. Security threats should be identified and security requirements derived, and also misuse cases should be derived. Role-based access should be specified. Security patterns and security principles should be applied, and the architecture should be reviewed for security flaws. A security test should be produced. For each iteration, the changes in the requirements, security threats, and security requirements and misuse cases should be identified. The architecture should be reviewed for security flaws, and the security plan should be modified. The domain model should be modified to understand security concepts introduced by use cases in the current iteration. During actor design, actor system interaction, and behavioral modeling, responsibility assignment, and deriving the design class diagram, design for security. Take into account the design requirements and misuse cases. Apply design patterns and security design principles and check for security-related flaws. During test-driven development, integration, and deployment, Consider security requirements and misuse cases. Apply static security vulnerabilities, analysis tools, test for security, and run misuse case-based tests and perform penetration testing. CMonster is a security modeling tool for threat models, namely attack trees and misuse cases, and can connect to repositories for sharing and reuse. PMD is a static Java code analyzer. Find bugs, looks for bugs in Java programs. Active user involvement is imperative. The users and customers know what the valuable resources are and the level of protection needed. Building secure systems require active customer and user involvement. The development team should work with the users throughout the life cycle. User involvement is critical during the requirements phase and when formulating security requirements and in assigning priorities to security requirements.